Welcome everyone. In this video lecture, we will solve a diode based problem which is from the Microelectronics circuits book. So this is just the continuous of my earlier video. So today we will solve these three diode based circuitry and we have to plot the output waveform. So the question is in each of the ideal diode circuit, so three ideal diode circuit where circuitry is there, input voltage Vi is a 1 kilohertz frequency and 10 volt peak sine wave. So this one is 10 volt and this should be minus 10 means 20 volt peak to peak. Okay, so SK is the waveform resulting at V naught. So what should be the waveform V naught and what are the positive and negative peak values? Okay, so first we have to go for this problem. So first of all, in such problem we have to identify diode is on or off. So in such situation we have to first find the transition voltage. So during the transition voltage, we have to give Vi some voltage. Okay, just same voltage you just give, and just think the current in the circuit is almost zero, and diode just conducts, and diode will just conduct. So in such situation, we are just thinking this current will be almost zero. This will be almost zero. Current will be zero, but this one will be just conduct. Okay, so this one is short circuited. So if we write the Kirchhoff's voltage law in this loop, okay, in this loop, so it will give the transition voltage. So this voltage will be Vi minus this one, so minus zero. Okay, this zero and this zero and this one is also sorted ideal. So Vi equals to 0 volt. This one is a transition voltage. If some voltage will be there, then we can say plus, suppose instead of this one, there is uh, silicon diode. So it should be 0.7. So where we have to write plus 0.7. Okay, so it should be Vi will be minus 0.7. So it is not there, so no need to worry. Okay, so the transition voltage will be our 0.7 volt, sorry, 0 volt. Okay, so first draw the circuit, draw the waveform. Okay, for more detail you can follow the Bolstead book. Okay, so this one is the waveform. Okay, input waveform. So this one is the transition voltage. You can directly say above this one is our transition voltage. Vi0 is the transition. Okay, so above Vi, the diode will be in the off state. Okay, for above Vi greater than 0, for Vi greater than 0, diode will be off, and below this, diode will be on. Vi less than 0, diode will be on. Okay, so in that way manner you can think, means, so simply diode will be forward bias during the negative half. Okay, so this one is the situation. So you can directly do, or this is the way, means how to find the transition voltage first, then after think, means above this it is on or off, like this. So when the diode is off, that is our Vi. When Vi is greater than 0, okay, so D1 will be in the off state. Okay, so that V naught will be same as that of Vi, because in this case the circuit will be, diode will be off, so it should be open circuited, plus minus V naught, and this should be plus minus Vi, this R or 1 kilo ohm. Okay, so 1 kilo ohm, 1 kilo ohm. So it is open circuited, so this V naught will be same as that of Vi. Okay, so output will be same as that of Vi in the positive half. So here I am doing. Okay, Clear? And in the negative half, Vi less than 0. When Vi is less than 0, D1 will be in the on state, and on state, so the circuit will be like this, and it is sorted. Okay, diode will be sorted, and it should be V naught, and this should be 1 kilo ohm, 1 kilo ohm, and this will be the Vi. So the output voltage we can find by using voltage division rule. V naught equals to Vi into 1 kilo ohm, this resistance, by 1 plus 1. Okay, 1 kilo. So Vi by 2. So it's minus 5 we can write, because maximum peak value in the negative is minus 10, so it should be minus 5. So it will go maximum. So we can say this value will be minus 5, and this should be our 10 volt. So minus 5, 10 volt. So here the V peak. So here we can say the V peak positive will be 10 volt. Okay, and V peak negative will be minus 5 volt. Okay, you can easily draw. So this one is the waveform. Okay, the waveform is like this. Clear? But we have to first transition voltage, and then we can, or you can directly say for the negative half, it is diode will be in the on state. So if on state, output voltage will be just the voltage divider rule. We have to Vi into 1 kilo ohm by 1 plus 1, so minus 5. So like this. This one is the waveform. Okay. Now we have to go for the next question. In the second question, okay, this one is the circuit. So what should be we have to do? The diode will be on for the positive half, this half. Okay, so when diode is on, this will be the when Vi greater than 0. Okay, when Vi greater than 0, D1 will be on state. So the equivalent circuit will be like this. It's a 1 kilo ohm, 1 kilo ohm. This should be V naught, and this should be Vi. Okay, so V naught will be simply our Vi for the first half. Okay, now when the Vi is less than 0 for the negative half, this will be off. D1 will be in the off state. Okay, so when D1 will be off, the circuit will be like this. Diode will be open circuited, and this will be 1 kilo, 1 kilo. This should be V naught and Vi. So V naught equals to just voltage divider, we have to write 1 by 1 plus 1. Vi 1 kilo ohm by, so Vi by 2. Okay. For maximum peak, it should be minus 5. When Vi is minus 10. Okay. When it is minus 10, Vi is minus 10, it should be minus 5. So here the peak, V peak plus will be simply our 10 volt, and V peak minus equals to minus 5 volt. Okay, so this one is the answer. Okay, and the resulting waveform, what we will do, the resulting waveform will be like V naught Vi. Okay, like this, means it should be 10 volt. Okay, it should be more. Okay, minus 5 volt. Okay, or here I can also do, means output will be like this one. Output will be like this for 10 volt, and okay, minus 5, and this will be 10 volt. Okay, so this one is the another one. Okay, we have to very careful, means very simply we can solve any problem, but we have to know when Vi is greater than 0, like that. So now this one is the question, the third one, the final one. So in this case, what we have to do, when Okay, I am writing here. When Vi is greater than 0. Okay, when Vi is greater than 0, say this one is say diode D1, and say okay, so D1 will be in the what? Vi is greater than 0, so D1 will be the off, and here D2 will be in the on state. Okay, it is connected negative, so D2 is the on state. So the circuit in this case will be how we will make. We know this should be sorted. Okay, and this will be the open circuit. Okay, so this one is 1 kilo ampere, kilo ohm, and 1 milliampere. So V naught will be 1 kilo ohm into 1 into 10 to power 3 into 10 to power minus 3 ampere. So it should be 1 volt. So V naught will be 1 volt. Okay, V naught will be 1 volt when Vi is greater than 0. Okay, so this one is the condition. V naught will be 1 volt when Vi is greater than 0. So if Vi is greater than 0, it should be 1 volt. Do this. Okay, it's like this. Okay, now second case, when Vi is less than 0. When Vi is less than 0. When Vi is less than 0, so we can say D1 is just forward bias on. Okay, clear? D1 is on, and D2, when Vi is greater than 0. Okay, when Vi is less than 0, so it should be on. Okay, and this one is also on due to this negative, or due to this negative. If this one, it will, this negative will come here, so we can say D2 will be off. Okay, D2 will be off because this is more negative than this, so minus 1 or something. Okay, minus 1 or something. So this is more negative, so D2 will be off. So in this case, what we can say, D2 will be in the off state. So the equivalent circuit, how we will make? This one is plus 15 volt, 1 kilo ohm, output is there. This should be open, and this should be Vi. Okay, so I am just writing Vi like this. Okay, and this one V naught. So if we apply KVL in this loop, what should be the, means this should be our V naught. So if we apply KVL in this loop, we can write plus V naught minus 1 into 10 to power 3 into 10 to power minus 3. This because this one 1 milliampere. These two current will be the voltage, and minus plus Vi equals to 0. So V naught equals to 1 minus Vi. So when Vi is less than 0, this one is the condition. Very important condition. Okay, and this can be easily identified by just applying voltage loop in this portion. Okay, plus V naught 1 kilo ohm minus 1 milliampere. Okay, and plus Vi equals to 0. It will give this value. Okay, so now we have to draw the waveform in this case. So what we will do? Okay, so what we will do? I'm just plotting the figures. Okay, so suppose this one is Vi and T. So this one for the last problem, Vi greater than 0, V naught will be 1 volt. Okay, we have already calculated. So Vi greater than 0, V naught will be 1 volt. Okay, yeah, clear. So for this one will be 1 volt. I am saying up to this one. Okay, this one will be 1 volt output is when Vi is less than 0, V naught will be 1 minus Vi. Okay, so when Vi is 0, when Vi is 0, it should be 1 volt. So it is will be there. Okay, now when Vi is maximum, say 1 minus Vi. Okay, so it should be 1 minus Vi. Okay, so it will follow the curve. Okay, and Vi equals to when it is 10. Okay, so it should be minus 9. So it will go like this. Okay, and up to this. Okay, clear this one. So here V peak will be 1 volt and V peak minus will be 9 volt. Okay, or minus 9 volt we can say this one. Simply we can plot like this one for the one, and then after it will go down. Okay, for different value. Okay, clear. So here the V naught equals to 1 minus Vi. Okay, this one is your minus Vi curve. Okay, so this is all about this one curve. So Vi is when 9, we can write this one is the curve. Okay, it should be more. Okay, clear. It is like this. Okay, minus 9, and this should be plus, sorry, 1 volt, and then after for, okay, no, and for this one it will be for greater than 0, it will go here. Okay, like this it will. Okay, so this is all about this question. Sure, thank you for watching this video. So like that you can solve any problem, but we have to very careful about the concept. Means in this question we can find means where the diode is on and off, all these things. Then we can say the output waveform we can easily draw. Okay, so this is all about the question, three question from microelectronics circuit book set by Smith. Okay, so thank you for watching this video.